Hey, welcome to Simply Electrical. We are going to be looking at a one-family dwelling service calculation. Now this is a 2023 code cycle, so keep that in mind. If you're looking for a 2020, I've got a bunch of other videos on the 2020 Calcs, and it covers everything from commercial to multifamily to single family, everything. And just check out my channel. I'll have a link in the description below for that. So we're going to do here the standard method on a one-family dwelling, and this is a deep dive, so we're going to go really into the nitty-gritty, and we're going to leave no stone unturned and take a look at exactly where this data comes from. Where do you get all the info for these calculations? I will also be putting out a crash course series that'll have the same method, the standard method on a one-family dwelling, but it'll have 4 or 5 examples that differ, that have different data in them, so that you can kind of get an idea of what you might run into in the real world scenario, or even on a state exam or something for a license. Okay, this is a table that I've developed that I think it makes it really simple for you to see everything at once. This is the whole calculation in one shot. That way you don't lose track, flipping back and forth between pages and so forth. So what we have here is, on the left side, we've got a lighting column, we've got appliance column, we've got dryer and range, and heating and cooling. What you do is you work from top to bottom, left to right, and you end up with your total answer down here in the lower right hand corner. And it's very simple, and as we go along, you'll start to see, it'll start to form a good picture, or a big picture for you, and you'll see how all the details fit in nicely, and why we take the approach we take here, and what the reasoning is for this order. I'm going to go through this fairly quickly here, but don't worry, I'm going to slow down and take it step by step as we go through the video. But basically you have your lighting column here, where you're going to take all of your general lighting loads, you're going to apply a demand factor to them, and you're going to come up with a total lighting load figure right here. Then you're going to get all your appliances, and also they're going to get in a demand factor sometimes, and we're going to come up with a total here for appliances. Then of course you're going to take your dryer, apply a table if you need to. Same with the range, use the table if you need to. Well, you most definitely will need to. And then you'll add those together and you get a total here. Heating, you're going to take heating or cooling. Then you're going to take the largest motor, figure that in. We'll talk about that in detail when we get to it. And you'll come up with a total here. I know it says heating total, but it also includes the largest motor. I just didn't want to make a fifth column over here just for a motor. So then you add all these together, the totals for each column, and you'll come up with a total for the whole building, a total VA for the whole building. Then you'll divide by your voltage, and you'll come up with your amps, and that'll be your service size. I also have some notes over here, but we won't talk about those until we get to the parts that those are relevant to. Okay, our first example here. Remember, this is a one-family dwelling. This particular one's going to be a 1,900 square foot house. It has 1,300 watt dishwasher, a 4,500 watt water heater, 1,100 watt disposal, 10,000 watt range, 4,800 watt dryer, 12 kW furnace, and a 6,500 watt heat pump. The service from the street is 120/240 single phase. That's pretty standard. And now the question is, what is the total calculated service load in amps? Okay, before we jump into the table, let's get our heads around the general layout of Article 220. So we're going to start with 220.40 and read this. The calculated load of a feeder or service shall not be less than the sum of the loads on the branch circuit supplied, as determined by Part 2 of this article, after any applicable demand factors, permitted or required by Part 3, 4, 5, 6, or 7 have been applied. So essentially all this is saying is that you're going to sum up your branch circuit loads according to Part 2, and then you're going to go to Part 3 and apply any demand factors that you find there. So let's talk about Part 2 and Part 3 and how they relate. Try to think of this kind of like bulk, like buying in bulk. So let's say you're going to buy some wire nuts. If you were to buy each wire nut individually, you're going to pay quite a bit for each one, right? Maybe 15 cents a piece. But if you were to buy a bag or a jug of 500, you're going to pay quite a bit less, maybe like 8 cents a piece, right? So you're getting a discount for buying in bulk. That's kind of the same thing going on here. If you were to tally up each branch circuit in part 2 and take everything in its full value, it'd be a certain amount. But then if you were to group them together and bundle them on a feeder, then you're going to get kind of a group discount, and your end result, your VA amount, is not going to be as high as it would have been otherwise. So I know that's not a perfect analogy, but that might be good for those who need kind of a visual to compare it to for this relationship here. So just keep that in mind as we talk about this. Now also, part 4 is another feeder and service calc, but it's an optional method. It's a different method. Part 3 is what we call a standard method, and part 4 is an optional one. It's just a different way to go about the same thing, and you'll come up with a little bit different result because of it. Usually it'll be a lower number, a lower value on the optional than on the standard. But in this video, we're just concerned with parts 2 and 3. Now there's also part 4, 5, and 6, or excuse me, 5, 6, and 7 up here. They are just for specific scenarios. 5 is farm loads, 6 is healthcare facilities, and 7 is boatyards and marinas. So we're not concerned with 4, 5, 6, or 7 in this video. The first thing we're going to do is take the square footage of our dwelling, which is 1900, and we're going to multiply by 3. Now why are we going to do that? Well, let's go to 220.41, dwelling units minimum unit load. It says in 1-family, 2-family, and multifamily dwellings, the minimum unit load shall not be less than 3 volt amperes per square foot. So what is a unit load? Well, unit loads include the following lighting and receptacle outlets, and no additional load calculations shall be required. All right, so it's going to tell us here with 1, 2, and 3 what the unit loads are. All general use receptacle outlets of 20 amperes rating or less, including receptacles connected to the circuits specified in 210.11c3 and c4. Now those are talking about bathroom and garage branch circuits. You can look that up in your code book. Second one is the receptacle outlets specified in 210.52e and g, and that's talking about outdoor outlets and basements, garages, and accessory buildings. And then the third one is lighting outlets specified in 210.70, and that's basically all the lighting outlets in the dwelling. So these 3 things, that covers everything in these unit loads. And we're going to try to find out how to arrive at this minimum unit load combined. So let's look at the next paragraph here. The minimum lighting load shall be determined using the minimum unit load and the floor area as determined in 220.5c for dwelling occupancies. Okay, we'll stop there for a sec. 220.5c. Floor area. So this is going to tell us how we are to calculate the floor area of a dwelling. The floor area for each floor shall be calculated from the outside dimensions of the building, dwelling unit, or other area involved. For dwelling units, the calculated floor area shall not include open porches or unfinished areas not adaptable for future use as a habitable room or occupiable space. Okay, so that's pretty self-explanatory. That tells us how to calculate floor area. So what this is telling us here about that is we need to take this 3 volt amperes per square foot and multiply it by our floor area, and that determines what our minimum unit load is. So let's make sure we keep these 2 terms straight and differentiated from each other. So you got the minimum unit load and the minimum lighting load. These are very different things, although they're related. So first of all, this tells us that you have to take the minimum unit load and the floor area to determine the minimum lighting load. So you're going to take the floor area, which is 1900 square feet, that's what we have, and we're going to multiply by 3 volt amperes because it's 3 volt amperes per square foot. So 3 times 1900 is 5700. And that number, 5700, covers all of these outlets in these 3 areas. And that's not all, because if we read on, it says motors rated less than 1/8 horsepower and connected to a lighting circuit shall be considered part of the minimum lighting load. Okay, so if you have a bathroom fan or sometimes a hood fan connected to a lighting circuit, those are generally less than 1/8 horsepower, and so they are going to be included in this as well. But if you have a motor that's more than 1/8 horsepower, or it's on a dedicated circuit maybe, then that would not be included in this, and you have to include that in the next column we'll get to, which is appliances. So I have it written here, minimum lighting load. This square footage times 3, that gives you your minimum lighting load. And in our case, that's 5,700 VA. Next, we're going to move on to our small appliances. And to find out the requirements for small appliances, we're going to go to 220.52. Small appliance and laundry loads for a dwelling unit. Okay, A is small appliance circuit load. In each dwelling unit, the load shall be calculated at 1500 VA for each 2-wire small appliance branch circuit as covered by 210.11C1. Okay, let's stop there. What does 210.11C1 say? Right down here it says, number 1, this is for dwelling units, small appliance branch circuits. In addition to the number of branch circuits required by other parts of this section, 2 or more 20 amp small appliance branch circuits shall be provided for all receptacle outlets specified by 210.52B. Okay, and that's going to point us to another coded section, but hang on, let's go back here and figure out what is this saying exactly. This is telling us that 2 or more 20 amp small appliance branch circuits are required. So up here we were told that each of these 2-wire small appliance branch circuits has to be rated at a minimum of 1500 VA, each of them. So now we know that there has to be 2 of them. So that means there's a bare minimum of 3000 VA for a dwelling. Okay, now let's go see what this is referencing here, 210.52B, and we'll come back. 210.52B, small appliances, receptacle outlets served. So this is telling us which receptacles it's talking about. So in kitchen, pantry, breakfast room, dining room, or similar area of a dwelling unit, the 2 or more 20 amp small appliance branch circuits required by 210.11C1, right there, shall serve all wall and floor receptacle outlets covered by 210.52A, right there. All countertop outlets covered by 210.52C, which that's all that is, talking about the countertop outlets in a kitchen. And receptacle outlets for refrigeration equipment, so like the fridge, freezer, things like that. So basically, all these outlets in the kitchen that are covered under these areas, those are what your small appliance branch circuit load is covering. So these minimum of 2 will cover everything in a dwelling kitchen, you know, as far as the small appliances in a dwelling kitchen. Now you may have a dwelling that has a huge kitchen and you may have 3 or 4 or 5 small appliance circuits, and that's okay, but you have to account 1500 VA for each of those circuits. So if you have 4 circuits, this would be 6000. In our case, we only have 2 because we're not told anything. We're not told about any extra circuits. So if you're not told about extra circuits, you don't assume there are. You just go with the bare minimum what you have to put in. So in our case, that would be the minimum of 2. 2 times 1500 is 3000 VA. So now back up to finish off this, we got where the load is subdivided through 2 or more feeders, the calculated load for each shall include not less than 1500 VA for each 2-wire small appliance branch circuits. Okay, so that's pretty easy to figure out what that's talking about. It's just saying that if you have this, say you have a panel and a sub panel, like one circuit is fed from one panel and one circuit is fed from the other panel, you still have to make sure that each one is given 1500 VA for the small appliance branch circuit. It's kind of a weird deal. That's usually not an issue, but they're just kind of covering themselves by saying it's got to be this way. You got to still keep it 1500 VA per each one. These loads shall be permitted to be included in the general lighting load and subjected to the demand factors provided in table 220.45. We'll get to that in the next slide or two. Now this general lighting load, that's very important because that's what we're trying to figure out here. That's what everything is kind of boiling down to. You see I got it written right over here. Or these first 3 lines here are going to add up to our general lighting load, this subtotal. Okay, now there is an exception here, and we got to talk about that. So in 220.52A, it says exception. The individual branch circuit permitted in 210.52B1, right here, 210.52B1. I don't have the exception written here, but there is an exception. Number 2, shall be permitted to be excluded from the calculation required by 220.52. Okay, so what this is talking about is there's an exception to 210.52B that tells us that we can bring an individual circuit, which is a dedicated circuit, to an appliance, and it can be 15 or 20 amps, And as long as it only serves that appliance, that does not have to be included in these two small appliance circuits. It would be on its own. So you could technically bring a circuit like just to the fridge. A lot of times we'll do that. We'll just bring the refrigerator will have its own circuit. That would not need to be part of this figure right here. You wouldn't have to add another 1500 for that circuit. You could, but you don't have to. It says it shall be permitted to be excluded. You don't have to exclude it. So anyway, that's what that's talking about. Not a big deal, not usually an issue. As long as it gets included either here or in the appliance category, they're okay either way. Okay, so now let's move on to laundry. Laundry, we have one minimum laundry circuit requirement at 1500 VA. Well, how do we know that? Well, 220.52b says laundry circuit load. A load of not less than 1500 VA shall be included for each 2-wire laundry branch circuit installed as covered by 210.11c2. Okay, let's go down, see what that is. 210.11c2 says laundry branch circuits. In addition to the number of branch circuits required by other parts of this section, at least one additional 20 amp branch circuit shall be provided to supply the laundry receptacle outlets required by 210.52f. This circuit shall have no other outlets. Okay, so it's telling us that at least one laundry branch circuit is required in any dwelling. Let's check this out. 210.52f. Laundry areas. In dwelling units, at least one receptacle outlet shall be installed in areas designated for the installation of laundry equipment. So if you have any area designated for laundry equipment in a dwelling, you have to add a laundry circuit. One 1500 VA laundry circuit minimum. And so that's what we have here. In our example, we're not told anything about laundry, so we have to assume that it needs one circuit minimum, 1500 VA. So now back up to finish off this. We got this load shall be permitted to be included with the general lighting load and shall be subjected to the demand factors provided in table 220.45. So this is the same phrase from part A up here. It's the same thing. So both the small appliance circuit load and the laundry circuit load are both part of this general lighting load. So once we have the minimum lighting load, which is 5700, and then we have the small appliance load and the laundry load, we can add those together and we come up with a general lighting load, 10,200. That's our subtotal. But remember, it tells us that with the general lighting load, we are permitted to apply demand factors provided in table 220.45. So that's what we're going to do next. Okay, so we just established our general lighting load and we came up with 10,200 VA. Well, now what do we do with that number? 220.45 tells us general lighting. It says the demand factor specified in table 220.45 shall apply to that portion of the total branch circuit load calculated for general illumination. So that's what we did. We calculated the general lighting load. Now it's telling us that this table, 220.45, will give us some demand factors that we can apply to that number right there. Now it also gives us this other sentence says, they shall not be applied, meaning the demand factors, shall not be applied in determining the number of branch circuits for general illumination. All that means is when you're tallying up your circuits, trying to figure out how many circuits you need for your dwelling, you can't use these demand factors in that process. You have to use the full rated amount. So that does not apply to our situation here because we're just doing a load calc for a service. Okay. So what do? We take this number that we calculated, the general lighting load, and we apply demand factors to it. So how do we use this table? First, we start over here, type of occupancy. We are covering a dwelling unit. So we take the first 3,000 VA, because this says portion of lighting load to which demand factor applies in VA. So the first 3,000 VA, we take it at 100% demand factor. So full value. And that's what we have right here on the first line. First 3,000 at 100%. 3,000 right there. So that 3,000 comes right off of the top of this. And that leaves us with 7,200, right? So what do we do with the 7,200? Well, from 3,001 to 120,000 VA, we take it 35%. So the next 117,000 VA, we take it 35%. Well, we only have 7,200, so we have to take that at 35%. And that gives us 2,520 VA. If we had more than that, we would take anything beyond 120,000 VA at 25%. Now we don't here, and it would take a very large house to get over 120,000 VA for your general lighting load. That's a huge house, but they are out there. So no, we just have the 3,000 and the 2520. We just add them together, and we get 5,520 VA for our lighting load, and that completes the first column. Moving on to our appliance column, we're going to go to 220.53, appliance load for dwelling units. It tells us applying a demand factor of 75% to the nameplate rating load of 4 or more appliances rated 1/4 horsepower or greater or 500 watts or greater that are fastened in place and that are served by the same feeder or service in a 1-family, 2-family, or multifamily dwelling shall be permitted. Okay, that's quite a mouthful. So let's break this apart. First, this 75% demand factor can be applied to the nameplate rating of a load of 4 or more appliances. So it's telling us that if we have 3 or less appliances, we have to take them at 100%. But if we have 4 or more, we can apply 75% demand factor to that. Now, that's only if these appliances meet certain criteria. They have to be rated at 1/4 horsepower or greater or 500 watts or greater. So if you have something that's less than 1/4 horse, or if you have less than 500 watts, then you can't include that in this 75% demand factor. You have to take those at 100%. Same with anything that's not fastened in place. It has to be 100%. So these are the stipulations, and they've got to be served by the same feeder or service. As long as you fall within these stipulations, you can apply the 75% demand factor to these appliances. Now there's another thing. The last sentence here says this demand factor shall not apply to the following. So here are some exceptions. Household electric cooking equipment that is fastened in place. So cooktop, oven, range, stuff like that. That's not included. Clothes dryers aren't included. Space heating equipment is not included. Air conditioning and electric vehicle supply equipment is not included. And the reason for that is that each of these 5 areas, they have their own particular requirements and ways and methods of figuring up their load values. So that's why they're not permitted to be included in this appliance load. Even though they are technically appliances, for this purpose, they're not included. So let's go ahead and fill in our data for our problem. Okay, so we have a dishwasher, 1,300 VA. We have a water heater at 4,500 VA. We have a disposal at 1,100 VA. Add those up, we get 6,900. Now, if it's 3 or less, that is our value. If we had had another appliance, we could have applied the 75% demand factor, but we don't, so we have to take it at 100%. So 6,900 VA is our appliance total. Next column is dryers and ranges. We're going to go to 220.54, electric clothes dryers for dwelling units. We'll take dryers first. So it says the load for household electric clothes dryers in a dwelling unit or units shall be either 5,000 watts or voltamps or the nameplate rating, whichever is larger for each dryer served. The use of the demand factors in table 220.54 shall be permitted. Okay, so this table 220.54 has demand factors that shall be permitted for dryers. Now the first thing it told us was you take either 5,000 watts or the nameplate rating, whichever is larger. So if you have a dryer that's 5,000 or less, that you just take 5,000. Even if it's like a 2,000 watt dryer, like a really tiny one, you still have to figure in 5,000. However, if you have a 5,500 watt dryer nameplate rating, you've got to put 5,500. Now, in most single-family dwellings, in fact, every single-family dwelling I've ever seen, you're not going to use this table at all, because if you look at it, it says the first 4 dryers are all at 100%. So until you get a 5th dryer, you won't be taking a demand factor at all. But once you do get to 5, then you take an 85% demand factor. So you would total them all up, multiply by 85 or multiply by 0.85, and that would be your total. So this chart is mostly for multifamily, so we're not going to talk about this chart much at all, this table. until we get to our multifamily calculation. All right, so that's what we put here. We have one dryer that's less than 5,000, so we put 5,000 VA. And I just put a little note here that says if you have more than 4, then use the table. Okay, now let's talk about this next sentence really quick. It says where 2 or more single-phase dryers are supplied by a 3-phase, 4-wire feeder or service, the total load shall be calculated on the base of multifamily. So you can go there, check out that on my channel, and you can get this explanation of how to calculate that. Okay, so this last sentence says kVA shall be considered equivalent to kW for loads calculated in this section. Now this is mainly the way we take kVA and kW anyway when we're talking about feeder and service calcs, because the difference between the kVA and kW is very negligible when talking about feeders and services, and so it's just not that big of a factor. It doesn't affect the numbers really at all. So we'll just use those terms kVA and kW pretty much interchangeably throughout these calculations. Now I have a whole video just on dryer calculations, so if you need any more information, I go really deep and heavy into the calculation and everything it takes to do a calculation, every type of calculation. I get into the single phase dryers on a 3-phase service and so forth. So if you want any more information on that, please check out my dryer calculation video. Now that we've looked at dryers, let's now turn to ranges. We got to go to 220.55. Electric cooking appliances in dwelling units. Now this also applies to household cooking appliances used in instructional programs, but we're not focused on that here. Okay, so this says the load for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances individually rated in excess of 1 3/4 kW shall be permitted to be calculated in accordance with table 220.55. Okay. Now also we see here that they, again, just like with dryers, they say that kVA and kW will be treated equivalent. Also, there is this sentence here that tells us where 2 or more single-phase ranges are supplied by a 3-phase, 4-wire feeder or service, the total load shall be calculated on the basis of twice the maximum number connected between any 2 phases. Again, this is generally only for multifamily, so it does not apply to us in this calculation. All right, so what does this tell us here? It tells us that table 220.55, which is right here, is going to give us demand factors that we can apply. Now, this is what we always call the range table, the infamous range table. Now, when I say range, I mean cooking appliances, electric cooking appliances. That's pretty common in the electrical trade, that we just kind of use range to cover all those cooking appliances when we're talking about calculations, because they're all calculated the same. So let's see what this table says. It says demand factors and loads for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances over 1 3/4 kW rating. And then it gives us a parentheses here, and it says column C to be used in all cases except as otherwise permitted in note 3. Now we're going to get to the notes on the next slide, but first let's take a look at this table and just kind of see how it's laid out and what it's telling us. Now we have 3 columns here, A, B, and C. A and B have demand factor percentage values. So these are percentages. This is really key to understand this, because you can really get confused if you get the columns mixed up. A and B are both percent values, whereas C is actually a kW rating. So this is 8 kW, 11 kW, 14, and so forth. This is 80%, 65%, and so on. So that's a key to take away from this. You can really get messed up, especially when you get down here, around here, where the values are pretty similar. You got 32 and 30. And you can get them mixed up if you're not careful. But anyway, you are able to use column A for ranges less than 3.5 kW rating. That's a little misleading, because actually it's only from 1 3/4 kW up to 3.5. I'm not sure why they didn't put that here, why they worded it the way they did, but it's a little confusing, because you could assume that if you didn't catch this up here, you had a 1.5 kW rating appliance, you might use this column, and they're telling you you're not supposed to be able to. This whole table is only for 1 3/4 kW and larger. And actually, the top value is in column C. It says column C is for not over 12 kW rating. So that's the max limit on the high side. Getting back though to column B, so well, A was 1 3/4 kW to 3.5 kW. B is 3.5 kW through 8 3/4 kW. And then column C is anything 12 kW and under. You can use column C for anything 12 kW and under if you want. Now what you're going to find though is some of your cases you're going to be better off to use A and B if you are allowed to, if they fit within the range of A or B rather than C. It's going to give you a lower value. But if you want to be quick and easy, you could just use C for everything under, that's not over 12 kW. Okay, so that's the basic gist of this. Now we're gonna, on the next slide, we'll get into the notes and go into this in quite a bit more depth. But I just wanted to give you an overview for now. And of course, being a single family dwelling, we're only gonna be dealing with the first couple of lines here, these rows, because in a typical dwelling, you don't have more than 2, sometimes maybe 3 on a big kitchen. You might have a cooktop, an oven, and maybe another oven or a range or something. But you don't really usually get more than that in one dwelling. You can though. You can have a separate kitchen area somewhere, like in a basement or something. You can get a couple more appliances. So anyway, most of it's going to be one range though. Okay, let's move on. Okay, let's dig a little deeper into this table 220.55. I'm not going to go into everything on this table because a lot of it's for multifamily, but I want to give you a good, solid understanding of what the table is about and how it applies to a single family residence. Okay, first, what we're going to do is we're going to get into these notes, and these can get pretty complicated, but as we break them down bit by bit, piece by piece, they do become much more clear, and you'll get a lucid understanding of what it's talking about. Now, what I'm going to do first is go to note 3 because we already mentioned this on the last slide. It says column C is to be used in all cases except as otherwise permitted in note 3. So column C is over here, so they're saying use that in every case unless it's permitted in note 3 to use something else, to use one of these columns. So let's go to note 3 first. Note 3 says over 1 3/4 kW through 8 3/4 kW. It says in lieu of the method provided in column C, adding the nameplate ratings of all household cooking appliances rated more than 1 3/4 kW, but not more than 8 3/4 kW, and multiplying the sum by the demand factor specified in column A or column B for the given number of appliances shall be permitted. Okay, so what that's saying is if your range or ranges or cooking equipment falls within these two categories, then you can use these two categories by multiplying the sum by the demand factors specified in these columns. So if you have one range that fits, let's say it's a 3 kW rated range, 3,000 watts. If you just have one of them, you can multiply 80% by 3,000 and that will give you your kW rating for that range. Now if you have one that's say 4, then you multiply that by 80%, 4 kW by 80%. Now let's say you have 2, then you'd multiply it by 65%, and so on and so forth. So it's really pretty easy. Now let's continue on in note 3. It says, where the rating of cooking appliances falls under both column A and column B, the demand factors for each column shall be applied to the appliances for that column and the results added together. Okay, so they're just saying if, let's say you have 2 cooking appliances, one is a 3 kW and one's a 4 kW. Well, that puts one in column A, one in column B. So you would just take them each individually, multiply their percentage, and then add the result together, and that gives you your total. So that's pretty easy to figure out. Okay, well, a natural question, when you come up to this and it says column C, okay, will work for everything not over 12 kW rating, and you think, well, what do I do if I have a 13 kW rated range? All right, good question. Then you would come down to notes 1 and 2. Now, if you just have a single range, you'll be under note 1. And note 1 says over 12 kW through 27 kW ranges, all of the same rating. So obviously if you just have one, this would apply. If you have two of the same rating, this would apply, or 3 or 4 or however many. Note 2, however, is from 8 3/4 kW through 27 kW ranges of unequal ratings. So that's the difference between these two notes. This is equal rating, this is unequal rating. Now let's take note 1 first. Note 1 says, for ranges individually rated more than 12 kW, but not more than 27 kW, the maximum demand in column C shall be increased 5% for each additional kilowatt of rating or major fraction thereof by which the rating of individual ranges exceeds 12 kW. Okay, now this is why people's eyes gloss over when they're reading this, because it gets a little bit confusing. It's just a lot of information in one problem, and that's just this one. It gets worse as we get further down. But all it's saying really is you take the maximum demand in column C. So if you have one range, we'll just say we have 1. The maximum demand in column C, which would be 8, and then you increase it by 5% for each additional kilowatt of rating or major fraction thereof by which the rating of individual ranges exceeds 12 kW. So let's say your range is a 15 kW range. So you're exceeding 12 kW by 3 kW, right? So then you have to do 5% of 8 times 3. Now, to make this simple, I made up a formula here, or this is the formula that I developed from this, and it is the column C value plus the column C value times the kW rating minus 12 times 5%, and that'll give you your total kW rating. So if you just plug your numbers in right there, you'll get your answer. And it's as simple as that. And I'm not going to go into great detail, like I said, on this. What I'll do is I'll make a video just on this table, and I'll go through every single scenario. So just be on the lookout for that if you have questions on ranges, because I know this table is really confusing for a lot of guys, especially guys that are just getting into it, and it's kind of all Greek to them. Okay, well, let's move on to note 2. So what if you have a couple of ranges or 2 or 3 ranges, but they don't have the same rating? All right, so now this is from 8 3/4 kW through 27 kW. And it says, for ranges individually rated more than 8 3/4 kW and of different ratings, but none exceeding 27 kW, an average value of rating shall be calculated by adding together the ratings of all ranges to obtain the total connected load. Now this is the tricky part right here. This is what a lot of people forget to do. Using 12 kW for any range rated less than 12 kW, and dividing by the total number of ranges. And then the next sentence is just exactly the same sentence as what's up here, because then you use that same formula up here. Once you get the average, you average your ranges, and then you just use the same formula. So let's look at this real quick right here. Note 2. So you average the kW of all ranges. So let's say you have a 15, 16, and 17 kW range. You average those all out, so that'd be 16, right? But anything, if you did have anything less than 12 kW, you would use 12 kW for that value. So if you had, okay, let's change that. Let's say you had a 7 kW, a 15 kW, oh no, I can't say 7 because it's got to be over 8 3/4. Let's say you had a 9 kW, and a 16 kW, and a 17 kW. So you would average those together, but instead of using 9 as your value, you'd use 12. So it'd be actually 12, 16, and 17. And whatever that average is, that would give you your new kW value, and then you would just plug that value into the same formula as note 1. And that gives you your total kW rating. So it's actually kind of easy. Once you understand what they're doing, what they're looking for, and you have the formula, you just plug in your numbers, and it's really a piece of cake. The rest of this, we're not going to get into because it's talking about branch circuits, because you can use this table for branch circuits for ranges. And so we're not going to talk about that because we're talking about feeders and services in this video. Okay, now that we know how the table works, let's plug in our own data from our problem. So we have a 10,000 watt range, so 10 kW, that falls under column C, not over 12 kW rating right there. So if we just have one of these, our value is going to be 8 kW. So it's as simple as that, 8,000. So that's what we're going to put right here for our range. Demand is 8,000 VA. Once we have that, and we already have our dryer, we just add these together and we get 13,000 VA for our dryer and range total. Now again, just a reminder, I say range here, but that is going to include any cooktop or oven if you have them in your calculation. So just remember that. This is for any cooking appliance that's fixed in place. All right, moving on. Okay, now we're going to move to our last column, which is heating and cooling, and we're going to go to 220.51, fixed electric space heating. Fixed electric space heating loads shall be calculated at 100% of the total connected load. All right, so there's no demand factors that are applied here, but also it tells us we don't have to add the 25% extra that we would if it was a branch circuit. And then it gives us a sentence here that says, however, in no case shall a feeder or service load current rating be less than the rating of the largest branch circuit supplied. So basically, your branch circuit can't be larger than your feeder, which I don't know where that would ever come into play unless you maybe had a feeder that was supplying a distribution panel for heating, like in commercial. That's pretty common in commercial. But I still don't know how you'd ever have a situation where your feeder would be smaller than your branch circuit. But maybe if some of you know of a situation like that, let me know in my comments, because I'm kind of curious to know when that would ever happen. Okay, so that's pretty straightforward for fixed electric space heating. You take 100% of your load. Now they give you an exception here, which I think is meaningless, because it tells you that the authority having jurisdiction, which is just your inspecting agency usually, that they are permitted to grant permission for an exception to this calculation or this requirement. But that doesn't make any sense to me, because the authority having jurisdiction is the supreme authority in any locality. And the NEC can't grant them permission for anything. It's the AAHJs that choose whether or not to accept the NEC. So I think this thing is meaningless. At most, maybe it should be like a fine print note, but not an exception. Anyway, that's just my 2 cents. Okay, now we're going to move on to 220.60, non-coincident loads. And you're going to see there's 3 sections here, 220, 51, 60, and 50. They are all interrelated. I know it seems like they're out of order right here, but this is the way I like to go through the process, and so that's where I'm going to lay it out for you. The non-coincident loads, the reason they're here is because in a residence like this, the heating and the air conditioning are going to be the main loads that are always referenced for non-coincident loads. They're really the only ones in a dwelling in most cases. So let's talk about non-coincident loads now, and then we'll move on to motors and AC next. Okay, 220.60 says, if it is unlikely that 2 or more non-coincident loads will be in use simultaneously, using only the largest loads or loads that will be used at one time for calculating the total load of a feeder or service shall be permitted. Okay, now that's very wordy, unnecessarily wordy. All they're saying here is if you have 2 or more loads that aren't going to be operated at the same time, at least it's not likely they are going to be operated at the same time, then you just take the largest load and use that for your calculation. That's all it means. So you take the largest of the 2 loads if they're not going to operate at the same time. If they do operate at the same time, then they're not non-coincident and you have to take them both independently. Okay, now that's pretty clear, even though it's a bit wordy. Now this next sentence is where there's a problem. The way they've worded this is not aligned with what their intent is, unfortunately. Now in the 2020 code, they added a sentence that messed everything up. Everyone was fine with this code the way it was for all these years. Then they added a sentence and it screwed everybody up, and everyone got confused for good reason, because it wasn't worded very well. Now in the 2023, they adjusted it, they amended it, but they didn't help their situation at all. They just added confusion to it, and it's disappointing, because I was hoping that they would have fixed their first error. But anyway, I'm going to read what it says, tell you what it means, and then I'm going to tell you what their intent was behind it. Okay, so here we go. If a motor or air conditioning load is part of the non-coincident load and is not the largest of the non-coincident loads, 125% of either the motor load or air conditioning load, whichever is larger, shall be used in the calculation. Okay, so if we were to take this at face value, what does this mean? They're saying that if you have a motor or air conditioning load and it's part of the non-coincident load, so it's not going to be on simultaneously with some other load, and is not the largest of those two loads, then you have to add 125% of either the motor load or air conditioning load, whichever is larger, and that'll be used in your calculation. So let's just take an example real quick. In fact, we'll use our example here with our problem that we're dealing with for this calculation. We have a furnace at 12,000 VA, right? 12,000 watt furnace. We have a 6,500 watt AC or heat pump. So let's apply this, what they said, let's apply it to our calculation. So if a motor or air conditioning load is part of a non-coincident load, okay, which it is, we have an AC or a heat pump that's part of the non-coincident load because the heater and the AC will never run simultaneously. The heater strips. Now remember, we're talking about the heater strips. Now the blower motor on the heater will run at the same time, but it's a pretty small load, so it's usually not taken into consideration unless you're getting really fine-tuned with this. But most of the time you don't have that information, so you can't use it. So you just kick the whole heater load as a unit always, and the same with the AC. Okay, so we have a 12,000 VA heater, and it's non-coincident with the 6,500 watt AC. So that is this right here. Our AC is part of a non-coincident load with the heater. And if it is not the largest of the non-coincident loads, which it's not, the AC is not the largest, then we have to add 125% of either the motor or air conditioning load, which I'm telling you, this phrase right here does not make any sense with their wording. Because now they're comparing the motor and the air conditioning load, which it just said if you have one or the other, then how do you compare the two if you don't necessarily have both? So it doesn't make sense. But anyway, what they're saying is you take 125% of, in this case, the air conditioning load, because that's what we have, whichever is larger, which again doesn't make sense, that shall be used in the calculation. So they're telling us that if you have two non-coincident loads, the first part says you take the larger of the two, which would be the heater, but then the second part says you take the lesser of the two and at 125%. So in our case, that means we would take the 12,000 VA for the heater and 6,500 VA plus an extra 25% and then add them both together. And that would be an astronomical calculation for us. In fact, that would come out to 20,125 VA, which is absurd. But that's exactly how they've got it worded here. Now let's take a step back a second and think about how this has always been taken in times past. Before 2020, we would always just take the larger of the two loads, and that would be what we used in our calculation. And that was easy. Then in 2020, they added the extra sentence, and so the assumption was, even though it didn't make sense as they had worded it, the assumption was that they were trying to reclaim some of that extra 25% of the AC or heat pump if it was the largest motor in the dwelling. And we're going to talk about that in just a minute, about the largest motor. But that's what I think they were trying to do. With adding this extra sentence, they were trying to reclaim that extra 25% of the largest motor if that was the biggest one in the dwelling. Because usually the AC compressor motor is the largest one in a house. So that's what I'm going with this calculation. And I did that in 2020 also. And I think that's pretty much the consensus of most people familiar with this. Can't get an answer out of the NFPA. I've written to them. So they haven't explained themselves on this anywhere I can find. It may be out there somewhere. But so that's what we've been going with. If this is for a jurisdiction, your local jurisdiction, you're on a job or whatever, you're trying to figure out this, you need to check with your AHJ, your inspection agency. You need to find out how they're looking at this. If this is going to be an issue for you. If this is for a test, you're going to have to just hope that their answers give you the answer, you know, as far as their options go. It's multiple choice. And so they will give you the information that you need basically for when you're doing motors and this kind of a calculation. They're going to give you the information you require. So it's usually there will be some hints so you'll know whether they expect you to add 25% extra for the heat pump or not. I wish I could be more confident in how they're going to view this, but because of their wording is so poor here, we're all left kind of guessing a little bit. But that's what I'm going to go with. That's what seems, I mean, it fits. It makes most sense to me that that's what they're trying to do. There's no other purpose I can see for putting this extra clause in here, this extra sentence, than trying to reclaim that 25%. Okay, now let's move on to motors, and that'll clear that part up for those who don't know what that rule is. So we'll move down to 220.50, motors and air conditioning equipment. Now this says new. This isn't really new. It's just that they kind of split this apart and reworded a little bit here in B. So it says motors, the conductor sizing requirement specified in 430.24 and 430.25, and the feeder demand factor calculation method specified in 430.26 shall be used to determine motor loads. So they're basically just telling you, go to 430, 24, 25, 26, and that's what you're going to use for your feeder calc loads as well. And all that really says is if you have a single motor, you've got to take an extra 25% of that motor in your calculation. If you have several motors, you have to take the largest motor at an extra 25%, and then the rest of the motors at 100%. That's all this really says here that matters to us. So what that means is in a building, if you have, out of all your motor loads in a building, and in this case the dwelling, you have to take your largest motor and you have to add an extra 25%. So that's what I have this little green shaded area for. The largest motor of the dwelling has to be taken an extra 25% and added to it. So in our case, it is the air conditioner. It is the heat pump, 6500 VA, and we got to add an extra 25%, which would be 1625 VA, and we're going to add that to our calculation. So now let's back up a little bit. Oh wait, before we go further, let's look at B down here. Air conditioning equipment. This really doesn't matter to us. I mean, it does, but it doesn't change anything. So it says the conductor sizing requirements specified in Part 4 of Article 440 shall be used to determine air conditioning loads for hermetic refrigerant motor compressors. And all it says in Part 4 is that anytime you have a package unit like an AC or a heat pump where it's all one unit and it's got a nameplate on it, you just use the nameplate. That's all it tells us in Part 4. So we need to use the nameplate rating for our AC, which we did, 6500. Okay. So now let's back up a little bit and look at this big picture. We're going to go back up to the fixed electric space heating. So we have a 12,000 VA furnace. So we put for our heater load at 100%, 12,000 VA. For our AC, we take it at the nameplate, 6,500. Then, because of their non-coincident loads, we have to decide which one is larger. And the larger of the two here is 12,000, the heater. So we take that at 100%. Then we factor in our largest motor, which is the heat pump, and we got to add an extra 25% to that. And that gives us 1625. And once we have that, we can add our 12,000 and our 1625 together to get 13,625 for our heating total. Now I know that was a lengthy explanation of this mainly because of this wording here is so suspect. And I hope in 2026, I hope they change this and either just nix this all together or make it clear that we got to reclaim that extra 25% if that's really what they want, which I think it is. They just need to make it more clear. And I know they've been getting a lot of feedback, a lot of backlash because of this. There's lots of forums out there you can look at and people are arguing over. I have a separate video just on non-coincident loads. I take the time to get into all the details of how to interpret Article 220.60 and apply it to a load calc. The video covers 2023, 2020, and pre-2020 code cycles. Check out that video if you want a more in-depth look at non-coincident loads, motors, and air conditioning loads. See the link in the description below or on my channel. Okay, now that all our columns are done, we have our totals down here. I have the example down here again just for reference, all the data that we had. And we just add up our 4 columns. So we add up the lighting total, the appliance total, dry and range total, and the heating total. And when we do that, we come up with 39,045 VA. That's our 4-column total VA for the whole building. Then we got to get amps, right? Because we got to size our service. So we divide by 240 volts, because that is our voltage here, single phase. And we come up with 163 amps, and that is our service size. It's as simple as that. Once we have that number, we can size our conductors, we can size our conduit, our service equipment, and all that. So this is a starting point for figuring out all your equipment sizing. Okay, now here I just have a white template. I've taken out the color so it's easy for you to maybe take a screenshot and you can print it up and you can practice on it as much as you want. So feel free to do that. Okay, hey, well, thanks a lot, guys, for watching, and I hope you found this helpful. If you did, please give me a like and subscribe if you would be so kind. I would really appreciate it. That helps me. It takes me a lot of time and effort to put these together, so hopefully one day I can maybe get a little kickback for this effort. But anyway, I appreciate you guys watching and your support, and we will see you on the next one.